It's trying to record. It's not working, but it's trying. Let's see. Hopefully this will begin soon. There we go. I think it's recording now. Hi, everybody. I hope your day is going well. I did have the request in class to go over a couple of the Cartesian plane transformations, in particular the one about rotating. Now, the main thing you need to know is about the rotating by 90, 180, 270, and of course there's clockwise and anti-clockwise or counterclockwise. Some parts of the world they call it anti-clockwise. So those are the main ones, and that's also if you want to refer to the cheat sheet where it takes the coordinates, does a little bit of a messing around with the coordinates, and voila, you can get your transformation. However, I also wanted to highlight how to rotate non-standard degrees, such as in this case 120 degrees, but you can use anything your little protractor is able to do. Speaking of protractor, if you haven't yet gotten one of these from me, please do. I have one for each of you, and that way we're not sharing, we're not having to disinfect them. I was finding the ink was wearing off when I was using the alcohol to wipe them down, so it's better if everybody just takes their own. Okay, so hit me up if you do not already have one of these. That's for people in my class, by the way. All right, and of course, you're also going to need a ruler. Any ruler will do, but it should be incremented by millimeters, just in case. All right, so we're going to just take a look at the document camera, go through 2 examples, and then if you have any questions after that, please don't hesitate to hit me up in Google Comments, on Google Classroom, or by email. Or in class, that also works too. And if you want other examples, today I'm just going to talk about rotation. All right, I'm going to switch cameras now, so I apologize. I don't have my fancy recording thing. Let me just switch that over. And there we go. So now, oh, sneak preview. There we go. That's the next one. All right, so right now we're just going to take a look at rotating by 90 degrees clockwise around the origin. So just a point, all of these tricks will work around the origin, and you have to have it around the origin or it gets a little tricky. Now, the second thing I'm going to show you, this one about 120, that will work even when it's not around the origin, but there's also another way. If you wanted to try this kind of quick rotation, as like the cheating way, where you manipulate the coordinates and you get a result, you can do that, not around the origin. If you translate your grid, so remember, we can move the object by translation, which is sliding, but we can also change our origin point and everything represented on it by sliding our grid. So you could also do a little bit of what I like to think is like the flip-flop math, which is where you do a translation of the grid and the opposite translation will happen for all of these. Because remember, moving the grid left is basically mathematically the same as moving the objects plotted on the grid towards the right. So it's like you're doing the inverse translation. So you could actually do these kinds of tricks not around the origin point. If you move your origin, it would still kind of, you'd end up in a different spot, maybe down here somewhere. Anyway, that's just a little side note extra. Let's talk about doing this the straightforward way, which is you take your coordinates, here they are, P, Q, R, and you run them through this little operation where you take your X and your Y and you switch your X and your Y. So the Y ends up going first, you invert them, and then you've got the opposite sign X. This is for a clockwise 90-degree rotation. So it's going around this way. And the X becomes the opposite sign of what it was originally. So let's go through a couple of examples here. So P, the point is -2, 7. Q is -3, 4. And R is 1, 5. So when I run them through that operation, pause right now if you want to do it yourself. Take that away so you can't see. All right. In the meantime, we're here for getting an explanation. I'll unfold my Post-it notes. And you can take a look. So here's what happens to our numbers. P prime, this little tick mark, is the image of P. And you see the Y has now become the first number. It is now the new X. And the X has now become the new Y. You've inverted those. But the X in this case, because you have to invert the value as well. You change the sign for that x. It was originally negative, and now it's going to be positive. It's like you're timesing it by -1. All right, just a quick reminder of your integer math. If they're the same sign and you multiply or divide, it becomes a positive result. If it is different, then it will become negative. So in this case, we're negative times a negative, it ends up being positive. Cool. Same thing here. You got your y becomes the new x in q prime. The x becomes the new y, and it used to be negative, so in this result, it will become positive. So I do that for all three of them, and then I plot my points, and that's where they end up. And you can verify that with your protractor if you want to, just to double check. Now, remember, when you're using your protractor, you want to align it with that origin or whatever your rotation point is right there. And then you want to align it properly with the point you're checking. So I'm going to start with Q. I'm just going to check Q just like that. Quick pro tip, some protractors, actually most, have the line is not the same as the edge of the protractor. So you want to make sure you're aligning the line to the point that you're checking. So there it is now on the line that reads 0 on the outside. Go around by 90 degrees, which is about here, and you can see that does align with our new Q prime. A little bit messy, but that ends up over here. Cool, so that's the cheat way, the quick coordinate manipulation. So you can try that out next time you want. Now, I'm going to move on to the other kind. This also works for a different formula for, or a different formulation if you're doing 180 or 270 clockwise, and it's the opposite if you're going counterclockwise. So this is the same, 90 degrees clockwise is the same as 270 counterclockwise. Anyway, worst case scenario, if you know how to do 90 clockwise, you could do it again, the same trick again to get 180, and again to get 270 clockwise, right? So you could use just one formula, or you can memorize all of them, whichever one you prefer. All right, let's move on to the other non-standard rotation. And this is above and beyond kind of the regular expectation, but I like to go over it because it's much, much, much more real. Most of the time, the world does not rotate nicely by 90s. It's going to be like trying to figure out 120 or 30 degrees or any of these. So you're going to use your protractor, you're going to use a ruler, you're going to use a little bit of patience and a couple of tricks. Now, I like this steps, 1, 2, and then 3. You don't have to do them in this order, but I find it useful. And also there is a trick to do it a little bit faster using some Post-it notes, but we'll come back to that in a second. So I am just going to first measure off my distances from the point to wherever I'm rotating from. In this case, that's the origin. All right, so I'm going to measure as accurately as I can on centimeters and millimeters because I am in Canada. And I'm going to measure from the origin to the point, or from the point to the origin, same deal. So, and then write it down somewhere off to the side where it's not going to get in the way of your mapping, of your plotting. So Q ends up being 2.4 centimeters away. I can measure P as well. That ends up being 3.5, and R ends up being 2.5. I jot that down off to the side somewhere where it's not going to get in my way. That's step 1. Step 2, I get out my protractor, and I'm going to be rotating this. I'm going to figure out my angle measurements and then do a little mark where the angles align. Now, the trick with this is we're going counterclockwise. So that means we're going to be going this way, not the other way. So I'm going to need my protractor to basically be upside down here. So I turn it over around and I align it to the point of rotation, in this case, the origin. This will work even if you're rotating not around the origin, though. That's one of the benefits of this method, although it's a little bit slower. I then align the origin and the point, making sure that it's that 0 line. Notice the interior when I'm going counterclockwise is 0. The exterior says 180. Just don't let that throw you off. It just depends on which way you're rotating. So I've got that aligned, and now I count around to 120. That's about here. Sometimes it takes a few tries to get it right on the line. So then I will mark where that 120 is. As you can see, I've already marked it here in pink. So that's the 120 rotation right there. Now I do that for each of these, and I align it nicely rotate it around, find that 120 point, and I mark it with just a little tick mark out on the outside. If you happen to have one of the hollow protractors, that can be handy, the ones with the little gap in the middle. Otherwise, just mark the end points. And I do all 3 points in this case. Once I've got all of those marks, I then move on to step 3, which is I need to align along the angle using my ruler exactly the distance that I wrote down before and mark that point. So for Q, I'm going to see it's right on that pink line. I align it carefully with the 0, and I will measure out exactly 2.4 centimeters. I really got to be careful here about that alignment. It's easy to accidentally get a little bit off and a little bit off on your alignment there too. And I'll then mark 2.4, which will be about there, which is our Q. I do the same for each one of these. So this is my P prime angle, and then I measure the P prime distance, which is 3.5, and I mark it there. Then I do the same for R prime. I've got all 3 points now. I can then connect them and then shade it in if I want to. All right, so that is the non-standard, non-90 degree or multiples of rotation, any direction, and this trick will work from any rotation point. Now, this takes a lot of time. So one of the tricks that I like to do is take a Post-it note so that I can map more than one at a time. You've seen me do this before probably, where I will take a Post-it note. Now this time, unlike previous, I'm going to align my Post-it note right along that x-axis. And if you look carefully, I can just see through. And I made one of these before, but the point is I can now track exactly where that y-axis is, and I can even do a couple of little tick marks just to help me stay aligned if I were to ever move this. All right, now once I've got those reference points kind of down, I can now plot because I can see right through them, and I can verify it by peeling it back, and I can now plot where those points are by tracing, right? So there we go. So, and I'm just going to make sure I label those because it'll make my life a lot easier when I've done the rotation. That'll be Q, and that'll be R. I've got my endpoints. If I want to, I can connect it. Now here's the trick. So I've got my Post-it note, and I know where that origin point is. That'll be the XY origin. And I still want to rotate this, right? Now I could rotate it based on one of the points, but instead, I'm actually going to rotate it based on the axis that I just marked. I have another one here that I already drew on, so I'm just going to save that. So what I'm effectively doing is taking my protractor, aligning it along the x-axis, so it is in line with the bottom of the Post-it note right there, and making sure everything's nice and aligned. I then do my 120 degree rotation, and I do a little mark where that is. As you can see, I've done this. Now here's the tricky part. Effectively, I'm going to unstick the Post-it and rotate that around so that the axis aligns with my new part. However, as you can see, it's a little long. This is where those hollow protractors are actually kind of good. I'm just going to use my ruler to align those so I know how far to rotate. So I'm just going to take it right in and spend a little bit of time trying to get this snug right in there. So it's aligned. That means I've rotated that whole image all the way around once with this Post-it. By the way, there is software to do this nice and fast, but we don't have it. So that's the way it goes. So we're doing this old school. All right, so here we go. I now have all my previously plotted points, and I can verify that this is now rotated. And now I kind of do this trick where I keep my eyes peeled exactly where that is, and then I put my dot. That's one way. If you have a marker, like some of the, you might be able to take a marker and press and just poke a little hole through the page to make your mark or let it bleed through. The other way to do it is you can just kind of go back and forth and be like, oh, there's my R. There's a P prime, and there's Q prime. And eventually you'll end up getting that mapped out. This was a little quick, but I think you get the idea. So I hope that helps you to deal with rotations that are non-standard or the standard ones of 90, 180, 120. If you have any questions or concerns, just get a hold of me. I'm happy to help you out. And thank you very much for listening and for watching along. and I will see you in class. Take care, everybody. Bye-bye. Thanks.